We're now going to change focus a little bit and talk about some of the internal mechanisms of Java streams. And I'm not going to give you a detailed view of how it works at this point. We'll talk about how it works later. I'm just going to give you an overview of sort of how it differs from other things that you may be familiar with. So we're going to talk about the differences between external and internal iterators in Java 8 and beyond. So historically, when people wrote Java programs, they iterated through collections externally. So what does that mean? So you'd have a collection with a bunch of elements. You'd have something like a for each loop or a while loop that used the iterator interfaces, and then you'd have your app code. That's kind of the way things looked like traditionally. So here's a simple example. We have a list of names, or we're going to use the Three Stooges names again for kicks. And then we're going to have a for each loop, go through every name in the list of names, and we're going to print the results out. So this particular syntax tells the compiler, go ahead and get each element in names list one at a time. And if you look carefully at your assignment 1B iterator example, you know that when you wrote, for example, the for each method, that you did something like this, and this actually triggers a call to the iterator for names list, just like you did for your code as well. And then we print the results out. Okay, so that's kind of the canonical way of doing things. Here's another way of doing things using the iterator pattern and the APIs that are part of Java that have been around for a long time. So in this case, we go ahead and get ourselves an iterator to the collection using the iterator factory method. And then while there's something left in the iterator, we go ahead and get the next item and print it out. And now you know a little bit more about how to write those methods, which are really pretty straightforward to implement. Okay, so that's the way things work with traditional Java. With Java 8 and beyond, when you use streams, instead you iterate through the stream internally. So rather than having this code using a for each loop where it calls back to your application code, instead what you do is you basically turn all the processing over to the stream, and it does all the work on your behalf. So here's an example of how this could be used. So once again, we have a list of names, our good friend, the Three Stooges, except now we're going to convert names list, which is a list, into a stream. So this is a sequential transformation. We're getting a sequential stream. And under the hood, it's using some other stuff we'll talk about shortly. And now we have a stream of strings. And then for each element in that stream, we're going to give it the println method reference to print the results out. So you can see that that's going to end up calling the for each method on that particular stream. And that's what's called a terminal operation, and that'll cause the processing to take place. It'll pull the data from the stream, from the names list, and we'll then go ahead and print the results out. So when to choose between the two approaches. So internal iterators, the ones that are built into streams, are most useful when you have complex stream pipelines. I think you'll probably agree that this code and this code, that's about the same, right? This code here, I think everybody agrees that's pretty easy to understand. I think you'll also agree that that code is a little easier to understand than the more explicit way of programming with the iterator interface. But you'll also probably agree that, this code here, the one that uses the streams, that's probably not that much different from the for loop version, the for each loop version. However, when you get more complicated stream pipelines, then the internal iterators really start to shine. And I'll show you a simple example here, and then I'll generalize it a little bit. So you can see here, we're going to have something that's going to say stream.of URL array. Let's say we had an array of URLs, so we convert that URL array into a stream. We're then going to go ahead and replace everything that said CSE.Wustel to DRE.Vanderbilt. We're doing a string replacement, so we're taking a string in for each string in the stream of strings. We're going to replace a portion of that string with another subsection, another subset of the string, another substring. and that'll then create a stream of modified strings. And then we go ahead and we convert each of those strings into a URL using this URL class and some other syntax. And then when we're all done, we can collect the results into a list of URLs. So arguably, that's a little bit easier to handle than writing it with loops. And I may show you an example of writing it with the loops in a second. Something interesting here is that whenever you have so-called checked exceptions in streams, it gets a little bit unwieldy. So here's another way to do it by using exception laundering. So you can have some really cool exception laundering capability to wrap a parameter that expects a checked exception with something that will convert the checked exception to a runtime exception, or a so-called unchecked exception. So I think you'll agree with me that this code is a little bit more verbose and ugly than that code. So that's just a quick overview of the concept of internal versus external iterators. And what I'm going to do now is show you a little bit more example to illustrate this in more detail.